Good morning. We are at a crossroad. In one direction, we see AI as the best thing that has happened to human civilization. And on the other side is AI that will profoundly damage society. We are here today because we think there is a way to bring AI to be the best thing that has happened to civilization. Thank you for being here. AI is already causing a lot of harm. This is an example of Zillow's AI going crazy, creating 304 million operating losses and 2,000 jobs lost overnight. Why? Facebook Prophet did not understand causality. It was simply fitting a curve to the data without understanding the cause and effect relationships. Here's another example of AI causing harm in society. There was an algorithm that was used by major insurance companies and major hospitals that was biased towards black people. Why was this? Because the algorithm picked up a spurious correlation between health costs and health needs. There is more. Actually, the internet is littered with examples of AI causing harm in society. This was Amazon's AI tool that shows bias against women. Over time, it learned that anything that had woman inside was not a preferred CV. Even when a woman was the captain of the chess club, that was discriminated against. More recently, Cigna was sued over the algorithm that allegedly was used to deny coverage to hundreds of thousands of patients. We had a more recent example where lawyers used ChatGPT to build a defense, and it turned out that they were citing imaginary case law in court. So current AI is already causing a lot of harm. And we really have three options. Option one is ban AI altogether. Who here would like to ban AI altogether? Okay, no one. We can heavily regulate AI. Who here would like to heavily regulate AI? Maybe one or two people. A little bit of regulation, yeah, that works. And we have option three, which is use better science to build safe AI. And how many people here would like to use or build better science? Okay, great. You're in the right room. And this is why our community is growing so fast. This is why Causal AI is growing so fast, because we're all passionate about the potential that AI can bring to society. We just need to make this technology safer. We need to understand how it works. We need to understand the cause and effect of every algorithm we put there in the real world. We want to make AI great again, and Causal AI is the way to do it. Well, okay, really, we want to make AI safe again, but I think that's what we all hear today, and thank you so much for being part of this exponentially growing community. I want to show you an example. This is a real example that we did with a major financial institution, just to show you the power of causality and having a unified language that humans and machine can speak. As most of you probably know here, this is a causal diagram. It's a bit of a simplified one just to illustrate the point, but it is from a real example. So this major financial institution was building an algorithm to decide automatically who to provide loan to. So it was an algorithm to help them decide whether to provide a loan or not. And they threw a lot of features, and they realized that postcode was the highest correlated feature to whether someone should be giving a loan. But they also saw that race and income are correlated, but they're like, okay, race we cannot use, of course, so let's throw that aside. But income seems like a fair game. If someone earns more, they should get a higher loan. And so they put income and postcode, and they shipped it to the model review board. The lawyers came back and said, we are really a bit concerned that you have a racial bias in this algorithm. We've done some tests. The team went back and said, well, let's build a causal model to try to understand this. What they learned by building a causal model was that postcode and race were correlated. And having postcode in the model, although it doesn't seem, seems benign, it's actually quite dangerous because it's hiding race in the information, right? Certain people live in certain postcodes. And so with the power of causal diagrams, they were able to remove this bias and said, okay, we cannot have postcode because that's hiding race. And therefore decided to use just income and other variables that they were able to quantify that they're not biased. And with the causal model, they were able to do something even more powerful. Not only they were able to explain to their customers why their loan was rejected, but they were able to tell them how they can be accepted in the future. They were able to tell them that if you increase your income by just 10%, we'll absolutely be able to lend you this for your dream house or for your dream kitchen. So not only, with the causal model, this financial institution was able to create trust with their customers. It was able to explain them exactly why the AI said you can't have it, and it was able to tell them exactly what they need to do in order to qualify for it. And that is the power of causal AI in practice. There was a great article in Nature which spoke about why artificial intelligence needs to understand consequences. And they went ahead and said that machines that grasp cause and effect can learn like humans through imagination and through regret. So our community is growing exponentially. So I decided to ask ChatGPT why causal AI is better. And it gave me surprisingly good answers. I couldn't agree more with it. The community is growing so fast, and the need for this technology is growing so fast because we want robust AI. We want the AI to generalize beyond training data. We want to decouple ourselves from historical patterns. We want to do counterfactual reasoning, kind of like similar to what I showed earlier. Things that are counter to the fact, by definition, are not going to be in observational data. We want to have fair and bias-free AI in our society, and I showed you an example for that. We want to be able to fully explain the AI and so on. So I thought this was a really nice summary of why our community is growing so fast and why we're all excited about bringing this technology in the real world. We have come a long way as a community. This is how, if you Googled causal AI in 2017, this is what you would have seen. It was us and Elias, who is a student or now collaborator of Judea Pearl. We were the only two people in the whole world talking about causal AI. If you were to repeat this Google search today, very different world. You'll see all the big tech, you'll see all sorts of large corporations incorporating causal AI. We've come a long way over the last years. And we're only accelerating. If you look at the number of newspapers, so Top Machine Learning Conference, we've seen yet another extrapolation of the exponential trend happening this year as well. We've seen huge investments from big tech in this technology. Microsoft and Amazon actually collaborated for the first time, as far as I'm aware, on an open source project specifically on the topic of causal AI. Causal AI is now on a bunch of Gartner hype cycles, and what's interesting between last year and this year is that last year it was a technology that was going to be adopted or predicted to be adopted in the next 5 to 10 years. In just a year, that horizon has changed from 5 to 10 to 2 to 5. So we've brought causal AI forward, and that's really exciting. We've also seen actually the EU regulation coming out and mentioning causal understanding as a key to safe deployment of AI in high-risk situations, much like the one I showed you earlier with the loan applications. That all is likely to be covered by the new regulations, and you can only have those models in production making decisions for real human beings if we can explain the cause and effect that goes behind that decision. In the last 12 months, we've also seen correlation being cancelled on Twitter for impersonating causality. So that's great. In the last 12 months, we've also seen exponential growth in generative AI. On the chart here on my right, you'll see the exponential growth in funding in Gen AI. On my left, you'll see that supposedly Gen AI will break the data centers. There's a prediction that there will be 76 billion of compute by 2028. So Gen AI is also exploding. Causal AI and Gen AI have been the two most exciting technologies and the fastest growing AI technologies over the last 12 months. And that is great. Now, both Gen AI and Causal AI, are not AGI, right? They're not perfect for all use cases, but they all have, great strengths and great, some weaknesses. Here, I wanted to show you some of the weaknesses of Gen AI. This is a very simple, math that you could do on your calculator. But LLMs are struggling to do that out of the box, without invoking additional libraries and writing additional code. So that's one area where the generative AI or the LLM specifically have failed, is doing basic mathematical computations. They don't seem to do very well with logic and reasoning. So if Mike's mom has 4 kids and 3 of them are Louis, Drake, and Matilda, what is the name of the 4th kid? For a human, it takes 3 seconds, we're done. For a language model that predicts the next word, this is a very tricky question. If you ask a Gen AI that generates images to build a salmon swimming down the river, you will get something that looks like this. There was a really interesting paper from Meta, ETH Zurich, University of Michigan, that asked a simple question. Can large language models infer causation from correlation? And the answer was basically no. They performed close to random on this task. So Gen AI is great. It has amazing use cases. But it cannot be used for logic, reasoning, computations, and use cases where we cannot tolerate hallucinations. But what if there was a way to combine the best of these two emerging and fast-growing technologies? What if there was a way to put causal AI and Gen AI together? What if we can find a way to get these technologies to play to their strengths? Maybe we can achieve 1 + 1 = 3. And I know the math is not right, but LLMs don't seem to care, so I thought I'll just put it there to illustrate the point. This is a real example, a real story that I heard from a CIO of a Fortune 100 organization. It's a tale of 2 teams. The first team decided to solve the use case just using LLMs. The second team decided to solve the use case by using LLMs and causal AI. So let's see how the results went with the first. I've taken out all the sensitive stuff here, so I can show you this. But this is how the conversation went with the team that used just as LLMs. So you can ask it, what is driving our customer retention? This was a retail example. And the LLM would say, well, the length of time the customer waits as a checkout. Seems like a very, very, very good answer. So great, that's awesome. But we want to know exactly how much. So we asked the LLM, can you quantify it for me? And then LLM can do things like, there's an inverse relationship between the wait and retention. And you can kind of see how this works because you may be able to find some academic papers that have figured out this relationship. So that's great, but it doesn't quite tell us by how much. So if we start asking the more interesting questions, like what should we do to increase the lifetime value of our customers, it tells us again something very sensible. Increase the number of staff at the checkout. But is it increasing it by 20%, by 50%? We don't know. It's a very intelligent answer, and it's correct, but we don't know by how much. And so when you dig deeper and you say, hey, tell me by how much, the LLM say, well, I can't quite compute that, but maybe if you give me some sort of a plugin, I might be able to write some code or invoke some algorithms. And so it was success, but they didn't quite solve the business problem. Let's see how the LLM plus Causal AI team did. They had the same challenge. They asked the LLMs. So in this case, you had LLM as an interface, so as a user interface, and then you had causal models underneath. So the LLMs were essentially the prompts were generating code that queries the proper causal model. So that's kind of how this looked like. And so we went through the same again. Okay, what is driving a customer retention? Same answer, great. But can you quantify it for me? And this is where the magic started happening, because now the LLM was not making things up. It was now writing code to query the causal models underneath. And it was able to say that for each 5 minutes of additional wait, the LTV decreases by 20% over a 1-month period. So that's very specific. That's really great. And a typical customer spends $100 a month, and if you don't do anything, they're going to spend $80. That's going to have a huge impact on your business. Natural question is, how do we fix this? What can we do to fix this? And the answer is that they need to increase the number of checkout staff by 13% in a bunch of stores and 70% at some other stores. Now we know what to do. Now we know how to make the business better, and we can trust this because it's been derived from causal models that were built by human and machine working together. So today I want to show you the world's first example of combining LLMs and causal AI. So I'll show you quick snippets of how this looks like in the real world, so you guys can so you don't have to imagine it. So here is an example of, very similar. What are drivers of churn? We have a causal model that has a causal diagram. This is invoking the causal diagram. We can see exactly how this works. So we're using the LLM as a user interface, but we're actually querying real causal models that were built by human and machine together. We're then able to do cool things like explain a very complex causal model to an analyst, to a human, exactly what are the mathematical functions that are between these edges. So we are, again, using this wonderful technology of GenAI to help us explain something that is quite sophisticated on the modeling side. We can query the causal models to ask for, what are the top 10 customers that are going to churn. It's a great way for the humans to interface with the machine. Again, we're querying the causal models, and we're getting a bunch of answers. This is also, I think, a great use of GenAI, where we want to actually take the action in the real world. Maybe we need to write an email, generate automatically an email to actually action our recommendation or our decision. In this case, sending an email to a customer automatically that they qualify for 16% discount that will prevent them from leaving the service. So this is the world's first combination of causal AI and Gen AI, and we think this is going to pave the future of decision making in the enterprise. In fact, we're not the only ones that think this. Databricks and .IQ ran a big survey of 400 AI professionals, and they asked them, what technology are you going to adopt next year? Causal AI scored #1 of not using right now, but have plans for next year. So we think that this synergy of causal AI and LLMs in particular are going to be the future of decision making. So if you had access to technology that allowed you to combine these two technologies, what use cases would you use them for to transform your organization? We can talk about this later. And before I wrap, I want to give you the heads up for something very exciting happening today. This is the last piece of the decision-making puzzle. We're launching Decision Ops today. And I'm not going to reveal too much because Tom will do a great job later unveiling this new capability. But in summary, we have taken Model Ops to a whole new level. We've taken Model Ops that simply measures model performance and tracks that to Decision Ops that can actually quantify the effect your decision-making systems are having on the ROIs that matter to your organization. And this is the last piece of the decision-making puzzle, and we're so excited to unveil it this afternoon, and Tom will tell you all about it and show you some cool, exciting demos. So do tune in for that. Thank you so much, and have a wonderful conference.